Hey class, so this is the second day of our final exam review. This is Digital Learning Day number 32, May 5th. We're going to just go over your assignment for today, but don't forget you also have a performance final. Okay. Now, what I'm going to do is I'm going to go over the questions just like I did in yesterday's video and do as much of it as possible, and you have to answer, find the final answer by yourself. Alright, so we're talking about exponential functions here, and this is a unit you all did pretty decent on. So let's start here with number 1. Okay, the points 0, 1, and excuse my messy handwriting, this is kind of hard to write with. So, 0, 1, that's a little bit better, 1, 5, 2, 25, and 3, 125 are on the graph of a function. Which equation represents that function? Whenever you have a set of points, you want to treat it like it's a table. Look at the x and y values and see if you can figure out what a pattern is. The x values are just increasing by 1, so I'm not too worried about it, but I do want to know, how do I get from 1 to 5, 5 to 25, and 25 to 125, or 125. Remember, exponential functions are a to the x power. That means we are multiplying or dividing a number to get, or dividing by a pattern or multiplying by a pattern to get the next number. So 1 to 5 is times 5. 5 to 25 is times 5. 25 to 125 is also times 5. And I'm going to change this to a b just for the sake of our formula. Okay, so remember, a equation is a times b to the x power. B is the pattern. A is the initial value. Now in this case, since our initial value is just 1, I don't need that a there because it's just 1 times something. Right? 1 times b to the x is just b to the x power. So you just have to decide, well, what's going to go into, or what's going to replace this letter here. Okay? So then now that I kind of gave you everything you need, go ahead and answer the question. Alright, so that's number 1. Let's go to number 2. Same thing. Okay, we're going to figure out what the pattern is to this table. I'm going to see if I can copy it over. And there we go. So now, look at your pattern. 8 to 40, since we're talking about exponential functions, just think everything is multiplying or dividing. Okay, so 8 to 40 is times 5. 40 to 200, also times 5. 200 to 1,000 is times 5. So based on what I showed you for number 1, what would the equation be? Right? Y equals a times b to the x power. B is that pattern. A is your initial value. Now, to find your initial value, x has to be 0, right? Because that's your y-intercept. 0 and then whatever this number is. Well, to figure out this number, you know you're multiplying 5 as x increases. So when you go back a step, right, how do you find, how do you find the previous term, right? You go backwards, you divide by 5. Okay, so from there, kind of decide which do you think is the correct answer. I'm going to tell you right now, it's not a, because that's a linear function. X by itself plus 7, that's a linear function. Okay, so it's not a, so it has to be B, C, or D. All right, number 3. Okay, same thing here. Let's see if I can copy it over. Okay, this is number 3. Oops. All right. Now, this is slightly different just because of the way it's lettered. Okay, same as number 2 with the table, but because this is n, okay, n is, when we talk about n, we're talking about sequences. So that is step number. So this is step 1. A sub n is how many tiles there would be if we're talking about those patterns, right? So in this case, this would be my x, this would be my y. Okay, so this means the same thing. So same thing, find the pattern. Anyway, find the pattern. And then I'm going to tell you right now that this is your initial value. That's going to be A. So then decide from here which of these 4 answer choices are correct. Okay? Let me actually write this down as well. Okay, you know it's going to be n minus 1, so it's A times B to the n minus 1 power for this equation. Okay, and that's the geometric sequence equation. So let's go to number 4 now. Okay, another geometric sequence equation. Just by looking at these, I kind of want you to just think about what is possibly not the answer. Okay, just use some test-taking strategies. Okay, the letter D, or choice D, is just wrong because that's an exponent of 4, which is something we never really talked about in a function. Right, so it's not D, so it has to be A, B, or C. So you have your tiles. Okay, step 1, step 2, step 3. Inside these tiles, there is 1 tile, 4 tiles, and 16 tiles. Find the pattern, same thing. How many tiles are there? You know that's times 4. And then kind of come up with the equation for that. Same equation, A times B, but because it's geometric sequences, we're going to use n minus 1. And this is number 4. Okay, number 5. Which function shows the function f of x 3 to the x power translated 5 units to the left? So when we did transformations, I gave you this. A times b to the x minus h power plus k. Anything in the exponent is horizontal. Okay, think h for horizontal. Everything that's big, okay, any base letters or constants are vertical. Okay, so that's vertical, and then the h is horizontal. I'm going to go 5 units to the left. Well, if I go left 5, that number is negative 5. Okay, so if I were to plug that in, so let's say I have, f of x equals, there is no a, so I'm just going to write 3 to the x power, but because it's left, it's going to be in the exponent, so minus negative 5. Well, you can't have a minus negative, so think about what you're going to do with that. Okay, think about what you're going to do with that, and then figure out what your final answer is going to be. It's going to be 3 to the x, and then something after it. Okay, is it minus? Is it plus? Now also think, is there a plus k? The question only talks about going to the left, not up or down, so use that to when you think about what the answer is going to be. Okay, so this is number 5. We're halfway there. Number 6. Population of squirrels doubles each year, or every year. Initially, there were 5 squirrels. Biologists studying the squirrels created a function to model their population growth. And you have your function here. P of t equals 5 times 2 to the t power, where t is the time in years, and you have the graph. We want to know the range. Well, remember, we started with 5. So we can't go less than 5, and it doubles each year. So we start with 5, then 10, then 20, then 40, and so on. So these are my range numbers, right? That's the total population. So it can't be any real number. That's positive, negative, and decimal fraction numbers. So it has to be one of these: whole number greater than 0, greater than 5, or greater than equal to 5. Okay, so you decide which one of these could it possibly be. Okay. All right, number 7. All right, so this one's very simple. Function graphed on this coordinate grid shows f of x, the height of the ball dropped in feet after its x bounce. Okay, x bounce just meaning first bounce, second bounce, third bounce, fourth bounce. On which ball was the height of the ball 10 feet? Okay, so we're looking, actually look at the y-axis first. We want the height to be 10. Go across and think about which bounce that is. Okay, so really, I don't even need to explain number 7 or write anything down for number 7. So this is number 8. Certain population has the average growth rate of 2%. You have this formula here. A equals P sub 0 times 1.02 T, or to the T power, where T is the time in hours. You begin with 200 bacteria. Okay, P sub 0 is the original population, so this is 200 times 1.02. So the question's asking, how many bacteria will there be after 100 hours? Type this in a calculator. If you do, especially if you're using a phone calculator, do this first. Okay, and then multiply by 200. Number 9. Same question as, let me see if I go back a few. Number 5. Okay. Number 9, we're talking about going down. So f of x equals 3 to the x power. We want to go down. So I didn't write this on the other one. Let's go ahead and write it here. All right. H is horizontal shift. K is vertical. Okay, and A is a stretch or a shrink. Okay, vertical stretch, vertical shrink. And I'm trying not to write too much on this because it's hard to write on this mini tablet, not the one I usually use. Stretch, shrink. Okay, now think about where the variable is, right? K is on the outside. It wants to know about 5 units down. Okay, well, 5 units down is something with a negative 5. Okay, so think about where is that going to go? All right, we're almost done. So this is number 9. Let's look at number 10. Okay, same question as that bacteria with question number, I think it was 8. Yeah, so let's look at number 10. It's a little bit different. Okay, you have your equation. Sample of 1,000 bacteria become infected with a virus. Each day, 1/4 of the bacteria sample dies. So we're decreasing. So number 10, P of T equals 1,000 times 0.75 to the T power. Now, the 1/4 is right here, this 0.75. Okay, what is the range of this function in this context? Okay, so we're going to get a fraction of the number of bacteria left over each day, right? So you start with 1,000 and you're slowly decreasing. So 1,000, then 25% of that or a quarter of that. So divide that by 4 is 250. divide that by 4 is, ooh, I can't do this in my head right now. Let's get a calculator. 62.5. That's why I couldn't figure it out, because it's a decimal. And then we keep going, right? So you notice that you're getting decimal numbers too, so you can't just be whole numbers, right? So it can't be B, and it can't be D. So then decide, is it A or is it C? Okay, how far does this divide down? How small does this number get to? Okay, all right. So let me write that here. So it's either A or it's C. Those are your two choices. All right, number 11, which function or which equation represents this graph? All right, the entire quiz or study guide on exponential functions, we finally come onto the one which just talks about the graph. Took them long enough. All right, number 11. When you have an exponential graph, you have an imaginary line called the asymptote. Okay, if you forgot what that is, just think about the joke we used in class to help you remember. Whoops, that's my other class. Okay, the asymptote. It's the line where the function never touches or crosses. So it's going to stop here. Well, what number is that on the y-axis? Okay, so that's 1, 2. So y equals 2 is the asymptote. Well, in an equation, exponential function equation, k is your asymptote. So whatever your asymptote is, this number is k. So I kind of gave it away. So now you just have to decide, well, what's the correct answer, A, B, C, or D? Okay. So I try to go as quickly as I can without rushing too much. Hopefully that helps. If you missed a question, look at the description below. There are timestamps for each question, so you can quickly go back to a specific question. Please don't forget, again, there is your performance final today. And also, if you're watching this before 1:45, there is a Zoom session that we will go over a performance final and these final exam reviews. Okay, I highly recommend and suggest that you complete these reviews because this is your mastery learning. I will replace any common assessment grade with whatever you get with these quiz grades. Okay? So just think about that. That's a great opportunity to get easy 100s or easy A's. All right? If you have any questions, I'll see you on the Zoom session. You can call, text. Some of you have my number now because I called your homes. If you need anything, let me know.